Welcome back. In this video, we're going to take a look at the discriminant. Now, the discriminant is the radicand of the quadratic formula. You may recall or have memorized recently the quadratic formula is that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, the discriminant is the part under the radical. It's the radicand. So the discriminant is the b squared minus 4ac. Not the square root of that, but we're just going to use b squared minus 4ac. And what the discriminant does for us is it tells us the nature of the roots of a parabola. While the quadratic formula tells us exactly where the roots are, or the x-intercepts are. The discriminant just gives us an indication of what the roots or the x-intercepts or the zeros or the solutions might look like. So, if the discriminant is greater than 0, if the discriminant is positive, the parabola will have two real roots, which means our parabola, if it has two real roots, it'll cross the x-axis 2 times. So our parabola might look something like this, with two x-intercepts, crossing the x-axis 2 times. If the discriminant is exactly 0, the parabola will have one double root, which means the parabola will hit the x-axis and bounce off. So here's our x and y axis. It'll just come and it'll touch that x-axis and bounce off. And maybe there's our one root. It might look like that. Okay? Now it might look like this too. The important thing here is that whichever possibility we have, it only hits the x-axis once. It'll just hit it once and bounce. So this is two different examples on the same Cartesian plane. Now, if d is less than 0, if the discriminant is less than 0, or if you will, if it's negative, the parabola will have no real roots. It will never touch the x-axis, but it will have two imaginary roots. So our graph of our parabola might look something like this. Whatever the case, it's never going to cross the x-axis. Okay? Now, it cannot look like this. Okay? This is not correct. Because eventually, this parabola will hit the x-axis. So, you got to be careful how you draw that. So, the kind of things I'll be looking for you to do with the discriminant are b squared minus 4ac is to use the discriminant to determine the number of roots of the quadratic and then describe the nature of the roots and sketch a graph of what the parabola might look like. So let's take a look at our first one. The opposite of x squared plus 4x minus 3 equals 0. And just like the quadratic formula, I strongly encourage you to tell me what a is, and b is, and c. So write down what a, b, and c are, then calculate the discriminant. The discriminant is b squared minus 4 times negative 1 times negative 3. And show your work. So the discriminant is 16. Negative times a negative times a negative is a negative. And we get the discriminant is 4. So my discriminant is a positive number. The nature of my roots is I will have two real roots, which my parabola will hit the x-axis twice. So my graph might look something like this, where it hits the x-axis 2 times. Let's go over and take a look at sample 3. That one looks a little bit more challenging because I don't have standard form. So I have to go ahead and put my equation into standard form. So I get 4x squared plus 4x plus 1 equals 0. Then I find out that a is 4, b is 4, and c is 1. I calculate the discriminant with b squared, so 4 squared minus 4 times a, which is also 4, times c. So I get 16 minus 16, which is 0. So now I know my discriminant is 0. So I have 1 double root. That is describe the nature of the roots. And then a graph with 1 double root might look something like that. Be careful to make sure I actually hit the x-axis. It's got to at least hit the x-axis there. Okay, so 1 double root is going to just come by and hit that x-axis and bounce back. Number 2, that one looks pretty straightforward with our a and b and c, but I will ask you to do that one on your own and bring that to class. So there is a brief introduction to the discriminant, and we will see you in class.